All right, moving on to the multiplication and division of multiple significant figures. Okay, have you seen this formula before? Density formula, mass over volume. Okay, to determine the density of an object. For example, this you if you take a Gen Chem lab, you get to do this experiment. It's like probably the generic common experiment. All right, so find it. If you want to find the density of this object, so you need to find mass and volume. How do you find mass? Well, use the scale, basically. All right, let's say if you read 4.7236, the last digit is uncertain. Okay, and the volume we're doing this, so we use a graduate cylinder. Have some water in it, and then add all this submerge this object into the water and look at the difference in volume. So we have initial volume and final volume. I subtract it for you, so you get 0.25 milliliter. The last digit is estimated. Okay. All right. To find the density, just plug in so mass over volume. That's it. All right. But now, I'm sure you can do calculator on this, but I want you to see, show you an example how to do multiplication and division using involved significant figures. All right. Start with the mass. How many sig figs are there? 1, 2, 3. So 3 sig figs. Okay. Oh, you can do the math right there. So there's 3 sig figs. The volume is only 2 sig figs, and the rule of doing multiplication and division is we take the significant figure of the result. It has the same significant figure of the one that have fewest significant figures. Okay, so right now we have 3 sig fig, 2 sig fig, we take 2, and we have to round this guy off to 2 sig fig. So that guy right there, so 8 higher than 8, so round them up, you get 19 gram per milliliter. That's it. Multiplication and division is much easier than addition and subtraction. Okay. All right. I'll have you try this one. So pause the video, do it on your own, and then check with me. A nugget of a shiny yellow mineral, so looks something like this, has a mass of that number in grams. Its volume is determined by placing it in a 100 milliliter graduate cylinder containing 56.3 milliliter. The volume after the nugget is added is 62.6 milliliter. So we have the final and initial volume. We have to subtract that. What is the density of the nugget? All right. So density, mass, and volume. So we have to find mass using scale. So we got that 56.28 grams. And find the volume. We have final volume and initial volume. Okay. All right. So mass on a scale. All right. Now volume. So use the water displacement experiment. So we have V final and V initial. So the volume of this nugget is 62.6 minus 56.3 milliliter, right down here. Okay, and we have mass at the top, volume at the bottom, and that's it. The rest is the math right here. All right. So subtraction. So 3 sig fig, 3 sig fig. The last digits are uncertain. Okay. So you the result of this subtraction gonna be 3 sig figs. All right. But by the way, so the first 6 minus 5, 2 sig fig, because the first digit is 0. I forgot that. Okay, so we got to 2 sig figs down here. All right. Now 6.3 at the bottom is 2 sig fig, at the top 4 sig figs. Division, we take the lowest number of sig figs, so 2 sig fig and 8.9. So 3, round them down. There we go. Ta-da. Okay, just to explain one more time, maybe you don't get what I mentioned earlier. So 62.6 minus 56.3, the last digit is uncertain, right? So the last digit is uncertain, right? 3 right there. But if you do subtract this, the first digit 6 and this guy going to be 5 later. So 5, the first digit is 0. So we have 0 right here. The only difference is 6.3. So we down to 2 sig figs. All right. And when you do division, we take the lowest number of sig figs, 4 sig fig versus 2 sig figs, so only 2. 8.9333, so only 2 sig fig, this 2. So you round down to 8.9. Okay, that's pretty much it. Division and multiplication. All right. The density of copper is 8.92 gram per milliliter. So it's likely that this mineral nugget of mineral is copper. Okay. All right, go to the next video.